Greetings of the day, dear students. In this video, we are going to discuss about the block diagram and pin configuration of 741 operational amplifier. What are the different blocks we are having in the block diagram, and also what are the different stages: input stage, intermediate stage, level shifting stage, output stage. All those things we will discuss, and also we will focus on the pin diagram of 741 operational amplifier. What are the different pins we are having, what are the names of the each pin, right, and what is the user purpose of the each pin, we will discuss in this video. Coming to the block diagram or pin configuration of the 741 operational amplifier, we are going to have four blocks. First one is the input stage, and the second one intermediate stage, level shifting stage, and the output stage. In this, for the at the input stage, it is going to have both the non-inverting input and the inverting input at the input of the input stage. Now it is also known as uh, it is going to have a dual input balanced dual input and output. Sorry, one second. The input stage is a dual and balanced output differential amplifier. It is a dual input balanced output differential amplifier. Now the two amplifiers are applied at the inverting and the non-inverting terminals, and this stage is going to provide the most of the voltage gain of the op amp and decides the input resistance value R I, right. Coming to the intermediate stage, the output of the input stage is given to the intermediate stage, right, and it is by the output of the input stage. And now the stage is nothing but the dual input unbalanced output differential amplifier, and the stage is going to provide some more additional voltage gain to the input signals. Coming to the level shifting stage, this is due to the direct coupling between the first two, due to the direct coupling between the first two stages. The input of the level shifting stage is nothing but an amplifying system with a non-zero level, right. So here with respect to now, in the output stage, it is normally the complementary of the this is normally a complementary output stage which increases the magnitude of the voltage and raises the supplying capacity of the operational amplifier, and it also provides the low output resistance. And the output stage is nothing but the push pull of the two transistors. So this is about the different stages of the operational amplifier. Now we will see the pin diagram configuration, pin diagram of the operational amplifier. Dear students, if you observe the pin that is very much nearer to this notch, very much nearer to this notch, this dot, okay, represents the pin number 1, and it is going to have 8 pins: 1 2 3 4 5 6 7 and 8. Out of those, the first pin is to be called as offset or null pin, and the second pin is the inverting terminal, third non-inverting terminal, positive sign will be there, and the fourth is the negative of the power supply, the supply that is required to drive this IC, right, operational amplifier. The negative of the power supply will be given or connected to the fourth pin. And similarly, the offset or null pin, fifth pin is called offset or null pin, sixth pin is the output pin, and the seventh pin is the positive of the power supply that is required to drive this op amp, and the eighth pin, extra pin, this is not at all connected, NC not connected pin, right. Again, out of these all 8 pins, we can classify them as the power pins, power supply pins. Pin 4 and pin 7 indicates the power supply pins, and the input pins, the other classification is the input pins. Pin 2 and pin 3, pin 2 inverting and non-inverting pins represents the input pins, and also offset or null pins, pin 1 and pin 5, pin 1 and pin 5 represents the offset and null pins, and the 8th pin is the not connected pin. These are the different pins we are having in the pin diagram. Out of these, if you observe, this pin 4 and 7 are the Negative and the positive voltage power supply terminals. This is the power which is required to the IC to function is received from these pins. Now most of the times the voltage level will be in between the range some 5 to 18 volts. Coming to the input pins, these input pins 2 and 3 represents the input pins of the operational amplifier. Now pin 3 is considered as the non-inverting input which is positive, right? And pin 2 is considered as the inverting input pin which is considered as the negative. When the voltage at the pin 2, if it is the voltage at pin 2, if it is very much greater than pin 3, which means that the inverting input has a high value of voltage, then the output voltage will be low. In the similar manner, if the voltage at pin 3, if it is very much greater than pin 2, then which means that non-inverting input has a high value of voltage. Non-inverting input has a high value of voltage, right? Now coming to the offset or null pins, what happens is operational amplifier is going to have an increased level of voltage gain. Because of this, even small variations in the voltages which can be both at the non-inverting and inverting inputs, there will be a huge change in the output voltage. For that sake, what happens is if there are any abnormalities in the construction procedure, or if there are any anomalies uh, in the constructional features, right, it shows a great impact on the output voltage of the amplifier. In order to overcome those, we are going to use this pin 1 and pin 5 as an offset or null pins. So this offset value of the voltage to be applied at pin 1 and pin 5. Okay, we used to apply some offset value of voltage to in order to overcome the abnormalities in the constructional procedure, or any anomalies present in the constructional features. Those can be overcome by using some offset value of voltage which will be applied to the pin 1 and pin 5, and generally this is accomplished, or this can be achieved with the help of a potentiometer. This can be achieved with the help of a potentiometer, offset or null pins. Now this is a pin 8 pin is the not connected pin. This is just a pin used to fill up the empty pin in the IC741 operational amplifier. It has no connection with any of the internal or external circuits. Coming to the concept of the virtual ground, you are having a concept called virtual ground. What does it means the voltage at the particular node is almost equals to the ground voltage 0 volts, but it is really not physically connected to the ground. Then such kind of node we can call it as a virtual ground. For example, here at this node is called the virtual ground, and its potential will be maintained at the ground potential 0 volts, but it is not really connected to the ground. It is usually maintained at the 0 volts potential, so that the difference between negative and positive inverting and non-inverting terminals, the voltage difference Vd will be equals to the 0 volt. This is called virtual ground. Now this concept will be very useful in the analysis of the op-amp circuits, and also it makes a lot of calculations very simple. So this is what all about the pin diagram and block diagram of the operational amplifier. Out of this entire discussion, dear students, the important point is it is going to have 8 pins. Out of those, second is the inverting negative, third one non-inverting positive. The power supply that is required to drive the IC is given to the positive power supply is given to the fourth pin. Negative power supply is given to the seventh pin. Now the output is taken across the sixth pin. If any constructional abnormalities or anomalies are present, those can be offset by using the offset null pins 1 and 5. Eighth pin is an extra pin which is not connected to any either internal circuit or external circuit, right? So this is what all about the pin diagram of 741 operational amplifier. Okay, thank you.